So today I am taking the new chapter limits and derivatives here. This is a very important chapter here because this chapter is useful in this year as well as the second year, even in engineering diploma and so on here. Okay, therefore this is very important chapter here. So first I am explaining about limits here. What is the limit? So first this is a definition here. A function f of x is said to have a limit here as x tends to a. If the absolute difference modulus of f of x minus l can be made as small as we please, whenever the absolute difference modulus of x minus a is sufficiently small, we then write symbolically as a limit of f of x as x tending to a is equal to l. Okay, this is a definition of limit here. I will extend this definition using one example here. Okay, consider the function here f of x equal to x square minus 4 divided by x minus 2. This is one function here. Suppose if you put x value to here, substitute x equal to here, then we get 2 square 4, 4 minus 4 becomes a 0 and 2 minus 2 becomes a 0 here. So 0 upon 0 is not a 0 here. 0 upon 0 is not a 0. It is not a particular number here. Hence it is said to be indeterminate form here. It is said to be indeterminate form. Therefore 0 upon 0 is not a particular number. It is an indeterminate form here. 0 raised to 0 is also indeterminate form here. Then 0 minus 0 indeterminate form. So similarly infinity divided by infinity, infinity raised to infinity, infinity minus infinity, these are all indeterminate forms here. Means it is not a particular number here. Yes, these are said to be indeterminate form here. Therefore, at x equal to 2, the function gives a 0 upon 0 indeterminate form here. Okay. Now, suppose if we draw the diagram here, therefore at the exact 2 here, there is a gap, means 0 upon 0 means it is not a particular number here, then you will get a gap here. This is a curve here, this is a curve, y is equal to f of x is this one here, therefore exactly at point 2, there is no value here, there is no value. Meaning is, if x is, at x equal to 2, it has no value means, but for other, it has a value here. We can consider what it has a value here. So we are taking a values from left side here. Okay, so 2 is there. Take the values from left hand side. Therefore take here 1.9. 1.9 comes here. Okay, then substitute 1.9 here and simplify, we get 3.9. Similarly 1.99 comes here. 1.9 nearer to 2 here. So then substitute here 1.9 and simplify, we get 3.99 here. Suppose x value 1.99 here, 999. Okay, 999 here. Then it gives 3.999. Therefore, when we are going the value nearer to 2 here, and the value nearer to 2, then this value nearer to 4 here. When x value tends to 2 here, then f of x tending to 4. Okay, when this value tending to 2 here, then here this value. So just observe here exact at this point here. Okay, consider this a point 4. Okay, at this point here, it is a 4 here, 4 value here. Therefore, when 1.9, this is 3.9. When it is 1.99, then it gives a 3.99. When 1.999, then it gives a 3.999, 3.9, 3.9999 and so on. Therefore, when this value tending to 2, this value tending to 4 here from left hand side here. Similarly, take values from right hand side here. Take a 2.01 at this point here. It gives a 4.0. Okay, so consider this is a 4.01 here. Then 2.001 substitute here and simplify, we get a 4.001. So 2.001 then comes here. Okay, 4.001 here. When it is a 2.0001, Okay, again nearer to 2 here, then the value comes here. Therefore 4.0001 here. Therefore when this value tending to 2 from right hand side, then this value tending to 4 here. Therefore when x tending to 2 left hand side, f of x tending to 4. When x tending to 2 from right hand side, in this case also tending to 4. Therefore when x values are tending to 2, in x value tending to 2, then this value tending to 4. In both cases it has a 4 here. Therefore limit of f of x, therefore we can say limit of f of x as x tending to 2 is equal to 4. Means the value tending to 4. It is not exactly 4 here, but tending to 4. Okay, ಇಲ್ಲಿ ಏನಾಗುತ್ತದೆ 2 ಇದ್ದಾಗ ಎಕ್ಸಾಕ್ಟ್ ಇಲ್ಲಿ ಗ್ಯಾಪ್ ಇರುತ್ತೆ, ಅಂದ್ರೆ 0.0 ಫಾರ್ಮ್ ಇರ್ತೀವಿ. 0.0 ಫಾರ್ಮ್ ಅಂದ್ರೆ ಇದು ಪರ್ಟಿಕ್ಯುಲರ್ ನಂಬರ್ ಅಲ್ಲ, ನಾವೇನಂತ ಹೇಳ್ತೀವಿ ನಾವು ಇಂಡಿಟರ್ಮಿನೇಟ್ ಫಾರ್ಮ್ ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. ಓಕೆ, ಎಕ್ಸಾಕ್ಟ್ಲಿ 2 ಇದ್ದಾಗ, ಬಟ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ 2 ಇದ್ದಾಗ ವ್ಯಾಲ್ಯೂ ಇಲ್ಲ ಅಂತಂದಾಗ ಅದ್ರ ಹಿಂದೆ ಬಂದು ನೋಡ್ಬೋದಲ್ಲ ನಾವು. ಓಕೆ, ನಿಯರ್ ಟು ವ್ಯಾಲ್ಯೂ ನೋಡ್ಬೋದು. ಈಗ 1.99 ಇಲ್ಲಿ ಬಂದಾಗ ಇದು ವ್ಯಾಲ್ಯೂ 3.99 ಆಗುತ್ತೆ. 1.99 ಇಲ್ಲಿ ಬಂದಾಗ ಅಂದ್ರೆ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕಾಗ್ತದೆ. ಇವಾಗ ಇಲ್ಲಿ 3.99 ಅಂತ ಬರುತ್ತೆ. ಹಾಗೆ 1.99 ಅಂತ ತಗೊಂಡಾಗ 3.99 ಅಂದ್ರೆ ಏನಾಯ್ತು, ವ್ಯಾಲ್ಯೂಸ್ ನಿಯರ್ ಟು 4 ಬರ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, ವೆನ್ ಎಕ್ಸ್ ಟೆಂಡಿಂಗ್ ಟು 2, ಯಾವಾಗ ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ 2 ಲೆಫ್ಟ್ ಸೈಡ್ ಇಂದ ಬರ್ತಾ ಹೋದಾಗ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ 4 ಗೆ ಸಮೀಪ ಬರ್ತಾ ಹೋಗುತ್ತೆ ಅಂತ ಮೀನಿಂಗ್. ಈಗ ರೈಟ್ ಸೈಡ್ ಇಂದ ತಗೋತಾ ಹೋಗ್ತೇವೆ, ಈ ಕಡೆಯಿಂದ ವ್ಯಾಲ್ಯೂ ತಗೋತಾ ಹೋದಾಗ ನಿಯರ್ ಟು 2 ಸಮೀಪ ಹೋಗ್ತೀರಿ. ಈಗ ಆಗ ಈ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ, 4 ಗೆ ಸಮೀಪ ಬರ್ತಾರೆ. ಅದು ಪಾಯಿಂಟ್ goes here like this. Therefore from this side again it is a 4, from this side again it is 4. Hence limit of x as x tending to not exactly 2. ಇಲ್ಲಿ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ, tending to 2 ಅಂತ ಹೇಳ್ತೀವಿ. ಎಕ್ಸಾಕ್ಟ್ಲಿ 2 ಅಲ್ಲ, ಈಗ tending to 2 ಇದ್ದಾಗ ನಾವು ವ್ಯಾಲ್ಯೂ ಏನಂತ ಹೇಳ್ತೇವೆ, 4 ಅಂತ ಹೇಳ್ತೇವೆ. ಹೌದಾ, ಇದನ್ನ ನಾವು ಏನಂತ ಲೆಫ್ಟ್ ಸೈಡ್ ಲಿಮಿಟ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಸೊ ಲಿಮಿಟ್ ಆಫ್ f of x as x tending to 2 minus 2 minus means it is a left hand side limit here, LHL ಅಂತ ಹೇಳ್ತೇವೆ ನಾವು. So it is said to be LHL, left hand limit here. Minus 2 minus ಅಂದ್ರೆ minus 2 ಅಲ್ಲ, minus indicates we are taking values from left hand side here. Therefore its values are 4 here. Then RHL means right hand limit here, limit of x tending to 2 plus here, f of x here. Here plus indicates you are taking a values from right side. Plus ಏನ್ ಇಂಡಿಕೇಟ್ ಮಾಡಂತಂದ್ರೆ ನಾವು ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನ ರೈಟ್ ಸೈಡ್ ಇಂದ ತಗೋತಾರೆ ಅಂತ. ಇಲ್ಲಿ ಸಹಿತ ಏನಾಗ್ತದೆ, 4 ಆಯ್ತು. ಹೌದಾ, ನೀವು ಲೆಫ್ಟ್ ಸೈಡ್ ತಗೊಂಡವ್ರಿ ಈ ವ್ಯಾಲ್ಯೂ 4 ಗೆ ಸಮೀಪ ಬರ್ತಾ ಹೋಗುತ್ತೆ. ರೈಟ್ ಸೈಡ್ ಇಂದ ತಗೋತಾವ್ರಿ ಅವಾಗಲೂ ಸಹಿತ ವ್ಯಾಲ್ಯೂಸ್ 4 ಗೆ ಸಮೀಪ ಬರ್ತಾ ಹೋಗುತ್ತೆ. ಅಂದ್ರೆ ಏನಾಯ್ತು, LHL is equal to RHL ಅಂತ ಇದೆ. LHL is equal to RHL. Okay, left hand limit and right hand limit both are equal here. Hence the limit of the function f of x as x tending to 2 is 4 here. ಈ ಲಿಮಿಟ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಬೇಕಂದ್ರೆ LHL ಮತ್ತು RHL ಎರಡು ಈಕ್ವಲ್ ಇರಬೇಕಾಗುತ್ತೆ. Okay, when the limit exists here, when LHL and RHL both are equal here, then we can say the limit exists here. Value of that limit is 4 units here. ಇಲ್ಲಿ modulus of f of x minus l ಅಂತಂದಾಗ ಇದರ ಡಿಫರೆನ್ಸ್ ನೀವು ಸ್ಮಾಲ್ ಮಾಡ್ತಾ ಹೋಗ್ತೇವೆ. ಈಗೇನು ವ್ಯಾಲ್ಯೂ ಇದೆ ಇದನ್ನ l ಅಂತ ತರ್ತೇವೆ. ಸೊ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ 4 is the value of l here. Okay, and f of x means these values. Okay, consider this x1 here, ಇದು x1 ಅಂತ ತಗೊಳ್ಳಿ, ಇದು x2 ಅಂತ ತಗೊಳ್ಳಿ, ಇದು x3 ಅಂತ ತಗೊಳ್ಳಿ, ಇದು x4 ಅಂತ ತಗೊಳ್ಳಿ, and so on. Then this becomes f of x1 here. This becomes f of x1. This becomes f of x2 here. Then this becomes f of x3. This becomes f of x4. ನೀವು this minus this ಅಂದ್ರೆ ಇದು ಯಾವ್ದು ಹೇಳಿ, modulus of x minus a. Modulus of x minus a means this value minus of this value. Then this value minus this value. Okay, this value minus this value minus this minus this minus this. When this value very small here, then this value is also very small here. So that's why the definition is what? A function f of x is said to have a limit L as x tending to a, as x tending to a. This is a is the value A ಅಂತ ತಗೊಳ್ಳಿ. Okay, this value is the area. Okay, so x tending to A, the absolute difference f of x minus L can be made as small as we please whenever the absolute difference modulus of x minus A is sufficiently small. Okay, ಯಾವಾಗ ಇದರ ಡಿಫರೆನ್ಸ್ ಸ್ಮಾಲ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, this minus this, this minus this, this minus this ಅಂದ್ರೆ the difference ಹೇಗೆ ಸ್ಮಾಲ್ ಆಗ್ತಾ ಹೋಗುತ್ತೋ ಇದು difference ಏನಂತ ಸ್ಮಾಲ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. When this difference is smaller, then this difference is also what? Smaller. Therefore, the definition of the limit is like that only. A function f of x is said to have a limit L as x tending to A. Okay, this value tending to 2L, then this value tending to 4. Hence, this is said to be value of A. This is said to be value of L here. So, therefore, tending to A, if the absolute difference f of x minus L can be made as small as we please. Whenever, this is important, yes. Whenever the absolute difference modulus of x minus A is sufficiently small, when this difference is small here, then this difference is also small here. Okay, then this difference is small. Therefore, when this value nearer to 2 from left hand side and right hand side, this value nearer to 4 from upper side and lower side here. Therefore, value of the limit is 4 as x tending to 2a, not exactly 2. Exactly 2 ಅಂದಾಗ indeterminate form ಅಂತ, ಈಗ ನಾವೇನು ಮಾಡ್ತೇವೆ x tending to 2 ಅಂತ ಹೇಳ್ತೇವೆ. Okay, so this is the notation of the function here, notation of the limit here. Okay, therefore in this example value of the limit is 4 here. Okay, so here left hand limit is a limit f of x as x tending to A minus is the expected value of f at x equal to A given the values of f near x to the left of A. This value is called left hand limit of f at A. Therefore, here it is a value A. You are taking a value nearer to A from left hand side here. When you are taking value nearer to A from left hand side, then this value move towards L here from this side here. Okay, therefore, when the value tending to A from left side, then this value tending to L from upper side here. Okay, therefore, this is called a left hand limit here. Similarly, limit f of x as x tending to A plus indicates you are taking values from right side here. Okay, plus indicates you are taking values from right hand side, minus indicates you are taking values from left hand side here. Therefore, limit f of x as x tending to A plus is the expected value of f at x is equal to A given the values of f near to x to the right of A. This value is called the right hand limit of f at x at A. Therefore, you are taking values from right hand side nearer to A, then this value tending to L from upper to lower side here. Okay, when you are taking values on this side, this value tending to L here. Therefore, this is called a right hand limit here. Then the left hand limit and right hand limit both are equal here. Then we can say the limit exists here. Then value of the limit is L here. Okay, therefore denote if the right hand limit and the left hand limit coincides, we call that common value as the limit of f of x at x is equal to A. Okay, at x equal to A, and denote it by limit f of x as x tending to A, or you can write a limit f of x as x tending to A. So algebra of limits here. So we are using these algebra of limits while solving the examples here. Examples solve ಮಾಡೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತಾ ಇರ್ತೇವೆ. So f of x and g of x, f and g be two functions such that both the limit f of x as x tending to A and the limit g of x as x tending to A exist here. Exist ಅಂತಂದ್ರೆ one particular value ಬರಬೇಕಾಗ್ತದೆ. Limit of f of x as x tending to a gives one particular value, not an infinity. Okay, not infinity. Infinity baba. Infinity bar does not exist on that. Okay, so it has a particular value. Means it has a value. Then we say that exists here. Therefore, limit f of x as x tending to a, limit g of x as x tending to a exists, then limit f of x plus g of x as x tending to a is equal to limit f of x as x tending to a plus limit g of x as x tending to a. Suppose instead of plus there is a minus. Minus is that limit f of x as x tending to a minus limit g of x as x tending to a ಅಂತ ಬರುತ್ತೆ. Then limit of f of x into g of x, product of the function. In that case, limit f of x as x tending to a into limit of g of x as x tending to a. Then also here product here. Limit f of x upon g of x as x tending to a is equal to then limit f of x as x tending to a divided by limit of g of x as x tending to a, where limit g of x not equal to 0, because if this becomes a 0, what happens here? Infinity. Therefore, denominator must be not equal to 0. That is important here. Next, limit lambda f of x as x tending to a is equal to lambda into limit f of x as x tending to a, where lambda is a constant here. Lambda is a constant or scalar quantity here. Next, limit nth root of f of x as x tending to a is equal to nth root of limit f of x as x tending to a. Okay, so examples solve ಮಾಡುತ್ತಾರೆ ಅಥವಾ theorems prove ಮಾಡುತ್ತಾರೆ ಇವನ್ನ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದಾರೆ. So these are called algebra of limits. Yes.